Okay, so this problem says, originally the ratio of Zach's amount of money to John's amount of money was 3-1. After Zach spent $10 and John spent $20, the same ratio changed to 5-1. How much money did the two boys have originally? And to do this question, as always, we are going to make the important sentences different colors. First sentence will be deemed the blue sentence, and second sentence is now the green sentence. Right, and to do this problem, since we're going to make a visual representation, we're going to make a table right after. That'll be our table. Right, anyways, now we'll write the names of two people in this problem, Zach and John, and we'll be representing their original amounts of money in these tables. We're going to use multiple representations. I'll just add another row. Anyway, so for the first representation that we're going to do, we're going to use the blue sentence to figure it out. The blue sentence says, originally, the ratio of Zach's amount of money to John's amount of money was 3-1. So to represent that, we're going to give Zach 3 hexagons we're using, and John 1. And just like that, we have represented the blue sentence. We can see the ratio is 3-1. Now we move on to the green sentence, which says, after Zach spent $10 and John spent $20, the same ratio changed to 5-1. So to do that, we're going to give Zach 5 squares this time we're going to use, and John 1 square. But you might recall that in the blue sentence, we represent the original amount of money each person had. So we're going to do the exact same thing with this representation. And to do that, we're going to give Zach back the $10 that he spent, and we're going to give John back the $20 that he spent. And now we can see that this is an original representation, as we have Zach's original amount of money, and if we were to take away the $10, we would have the 5-1 ratio. And the same applies with John. Now that we have done that, we're going to make another representation so we can compare. We'll make the representation here. We'll compare. Right. And to do this representation, we're going to look at John's two amounts, or no, John's two representations. Sorry. We see that in the blue sentence, John's amount is 1/3 of Zach's amount. So if John were to have 1/3, Zach would have all 3/3. So to show that, we can see that Zach's amount is 3 times John's amount. And if John's amount can be represented by a hexagon, as we saw in the first representation, it can also be represented by a square plus $20, because we said both representations for John show the original amount of money that he had. So if we can make another representation for Zach with 3 squares plus $60, since Zach's amount of money is 3 times that of John's. And if John's amount is 1 square plus $20, if we triple that, we get 3 squares plus $60. So we'll make that. Right, now we can see it better. So we said before that all of the representations show their original amount of money. So both blue representations show Zach's original amount of money. And since the amounts are equal, if we were to take away the same thing from each of them, they're still equal, right? If we take away 3 squares from each, we're left with 2 squares and $10 and $60. And since that's equal, we know that $60 is 2 squares plus $10. So what is the value of each square? To find that, we're going to subtract the $10 from the $60. And now we're just left with the squares. That means the squares, 2 squares, are worth $50, since that's what's left. Meaning 1 square would be worth $25. And since we have found out something very important, and this will help us find out the original amount of money each boy had, we're going to write it down. Each square represents that $25. This is very important, so keep it noted. Now we want to find out the value of each hexagon. And to do that, this time, we're going to compare two representations that John has. We're going to compare the first one and his second one. Simple enough. So we can see in the first representation, we have 1 hexagon. And in the second representation, we have 1 square plus $20. And we know these are equal as well, since both represent the same original amount of money John had. So if 1 hexagon equals 1 square plus $20, how much money does a hexagon represent? We know that 1 square is worth $25, and we also have $20 here. So in the second yellow cell, we have $45. So if a hexagon is the same as $45, each hexagon must be worth $45. And we'll write that down. Now we look at the last part of the question. The last part of the question, the not colored bit, says, how much money did the 2 boys have originally? And now, since we know the value of each of the shapes we used, we can figure that out. So we see that John has 1 hexagon, and we know that each hexagon represents $45. So John must have $45. And we know that each hexagon represents $45 again. So if Zach has 3 hexagons, he should have $135 in total. So now we know the original amounts of each. We can write that down. Zach originally had $135, as we said. And John originally had $45. And that is the answer to our question here.